Right. So today we'll be training a machine learning model, and then we'll be deploying it on Fast API. So the model basically is to predict if a customer will churn, or will they leave us, or will they come back and maybe buy from us. So that's what we'll be doing today. So first we'll have to do some setups for doing the actual coding. Maybe I'd like maybe one of us to share their screen so that we can work with them. So someone who is asking the relevance of the project data engineering. I don't know. Ni mbaya kujua machine learning? Si mbaya. So the relevance, I don't know if there is actually, I can say there's a relevance, but also but it doesn't hurt to know machine learning as a data engineer. Ama? Yeah. And given that data engineers are the ones who will be sourcing data for data scientists, CPA, it's good to know what that data that you've sourced for them, what it's doing actually, what they're using it, how they are using that data that you've sourced for them. So I can see there's someone who's shared their screen. Nani ameshare? Yeah, Burundi browser. Okay, like just go back to the meeting. So we have Mary Nyambura, she's shared the screen. So I believe everyone has a GitHub account, right? So nataka we create kila mtu to create a GitHub repo, a new GitHub repo for this specific project. Mary Nyambura, can still share your screen. Because there are some who don't remember how to do the same, so just name it telco customer churn prediction. Then can add a readme. Create repository. No, you can clone that repo. You can clone the repo. The one that you've created. I hope everyone is following what she's doing. Just click on that green button over there, the code button. There's a green little button here, green button with code, yes. Then click HTTPS. Now copy this link. There's a copy icon over there, yeah, there. So you can go to your file explorer. So where you want the project to be. So, is this the folder desktop where you want your project to be?
Yeah.
Okay, so right click on any white space, show more options, open Git bash here. So when you open Git bash here, it will open at that specific location that you are. So you'll just write git space clone and then paste that link. If you use Control V in Git bash, it has a different meaning. Just right click, paste, or you can use Shift insert if you have the insert button, although sometimes it jumps. Enter. All right, so now I think we have like a folder that we'll be working with. What's next? Next is you can now confirm if it has been created on your folder. Should come as in form of a folder. Yeah. So you go to your VS Code and then you'll open that folder. Because that's the folder that we'll be using. All right. Yeah, so I hope everyone has been able to do what she's done so far. So now I think you can now go back to the repository with the project and the description. The Lux repository.
Excuse.
Hey,
What has she done after pasting the
enter.
link on GitHub?
You press enter.
Oh, that's all.
Uh, uh, Bernard, I hope you've been able to clone the repo. Anyone who has faced an error before you proceed? Anyone who hasn't been able to create the repo clone? Okay, so I think we can start by understanding what specific problem are we solving by creating this model. So what basically we are doing is, as the project overview says, we are building an end-to-end machine learning solution that predicts whether a telecommunications customer is likely to churn. Churn means someone stops or ceases to use your services. Yeah, so to churn is like to stop, basically. So we are predicting if a customer will continue using maybe a specific service from the telecommunications company, or they'll be still using the services of that company. So the first step we'll do is we'll be loading the data, seeing how the data looks like, understand each column. I don't know if the column names have been defined here. I don't think so. Let me share with you a link. So there's a link I've shared on the chat. And the data set was sourced from. Right, so you can scroll to where the columns are. Let's scroll. Let's scroll, I'll tell you, yeah, there. So we have the first column, which is customer ID, which is a unique identifier of that specific customer. Then we have gender, which means which represents the gender of the customer, if they are male or female. We have senior citizen. So this is whether someone is senior citizen. Senior citizen, I think someone who is of an elder age. And then we have partner. This is whether the customer has a partner or not. You can scroll horizontally. I think there's a scroll. Let me check. Not just scroll kidogo vertically, and then you'll try and scroll towards the right. Yeah, so there's that scroll bar hapo chini. Yeah, just scroll juu kidogo ndio we see the actual column names. Huh. Let me just share the screen on my end, then you'll share after. Let me just share mine.
Manuel, we are talking, you're on mute.
Oh, sorry, I didn't know I was on mute. So the next column was dependents. Is whether someone has some people who depend on them or not. And then you have tenure, which is the number of months the customer has stayed with the company. So after Kenya, you have phone service. So whether the customer has a phone service or not. The next column is multiple lines, which is whether the customer has multiple lines or not. So yes is if someone has multiple lines. No is if they do not have the multiple lines, and then no phone service. I think it's if they do not, you have not subscribed to that specific phone service. Have internet service. So these customers, internet service provider. Have online security. So whether the customer has, so I think from phone service, multiple lines, internet service, online security is more or of the number of services or the types of services these companies are offering. Then we have online backup. So this is whether the customer has online backup or not. Device protection. Also, I think it's one of the services rendered by the telecommunication company. So this is whether the customer has a device protection or not. Tech support is whether the customer has tech support or not. Streaming TV, whether the customer has streaming TV or not. Streaming movies, contract. So I think these up to the streaming movies, these are the services that telecommunication companies offering. And you have contract. This is a contract term of the customer. So you have month to month, 1 year, you have 2 years. You have paperless billing, whether the customer has paperless billing or not. The payment method or the method that they use to pay for the services. There is monthly charges, total charges, and then finally we have churn. What will be training a machine learning model to predict. So yes, is if someone is likely to churn or not to subscribe back to their services, or no, which means someone will continue to use the services. Yeah, so that's basically what each of the columns in the dataset means. So after you understand what each column represents, the next bit is you'll be downloading that dataset. And remember that repository that we've created and cloned, that's like will be like our working folder. So you create other folders inside that folder, and maybe give them like we'll be creating other folders to arrange our work in a presentable way. Yeah, so I think Margaret, you can share your screen back. Oh, it was Mary, not Margaret. Mary Nyambura.
You're still sharing. Mary, you can go to the Lux GitHub repo.
So there's a folder there. Just scroll up to the top. So there's that data folder. You can click it, open it. The data is there. So that's the data set. Try to open it. On the right, where there is raw copy. There's a download icon over there. Yeah, so that's where we'll be downloading from. Can try and zoom in. Just try and zoom in and download too. So there's that download icon over there. Yeah, you can see it is downloaded. Now you can go back to your file explorer. Copy the downloaded datasets. I think it's under downloads. You can go to where downloads is. Oops. Yeah, it's there. That one. Just copy it. Copy. So create a new folder. Name it data. Just there. Yeah. Create new folder. Name it data. Now you'll paste that data set inside that folder that we named data. Paste. Yeah. So I hope everyone has been able to do the same. So I'd like you to create another folder, call it notebooks, where we'll be storing our Jupyter notebooks. Not there, go back one step behind and then, yeah, create. Notebooks. Then you can create another one, call it API. That will use its way later. Now go back to your VS Code. Anyone who is left behind? Online physical. Anyone who is stuck? All right, so link you can proceed if everyone is okay. So create a new virtual environment. Open the terminal, open your terminal. So just go back to VS Code. I'll show you where to open it. So you see the 3 dots on top? Yeah, like that's it's supposed to be terminal. Or you can just close that and then open. There's those 3 dots on the top after go. Where there's go after go. Yeah, trust folder and continue. So you can create a new virtual environment there. So it has created and activated automatically. So for the ones whose virtual environment won't activate themselves automatically, this is what you do. You write venv, then / venv is probably that the name of your virtual environment, the way she is named as venv, and then / scripts with a capital S, then / activate. So after you activate your virtual environment, I want you to install this. Install the libraries that I've shared on the chat. So we'll install those libraries. Maybe we'll be installing others as we proceed. For now, we'll use those. For the first API, don't. Wangechi says we are really fast. Where are you stuck, Wangechi?
I'm not stuck. I feel like you're going very fast. Kindly.
So let me give you like a few minutes for the ones who haven't set up yet. So the reason why we create virtual environments is we want to create like a secluded environment of the modules that we'll be using, so that they'll not be affected by any, for example, feature updates, because these libraries tend to get regular updates. So, for example, you might see that the pandas that was being used last year is not the same version as the one that's used in today, or maybe even tomorrow. Could be a different pandas that is being used. So due to that difference in the versions, it might cause compatibility issues, which is likely to make your code to raise errors. So to avoid that, we create virtual environment where we have our modules or libraries installed in an environment that it's tamper-proof. So because if you install them in the global environment, sometimes they might update themselves. Yeah, so you always use a virtual environment, create a virtual environment for any project. So when you want to run your project in future, you won't be facing some errors that arise from compatibility or mismatch in the versions of those specific modules. And then when it comes to virtual environment, you can actually, after you are done with your project, because it occupies a very huge space, so after you're done with your project, you can delete it. But before you delete it, you have to create like a requirements .txt file. That file basically contains like all those versions of all the versions of your modules that are installed on your virtual environment. So you can, if you want to rerun your project in future, you can just create another virtual environment, install the same versions of libraries that you have in your requirements file. So as they're installing, I'd like you, Mary, to create a .gitignore file. So the file is supposed to be in your root file. Yeah. So you first have to add that dot. Yeah. So you can see there is now an icon that has appeared that looks similar to the Git one here. So enter. So the .gitignore file is the file we add files and folders we do not want to push to GitHub. So in our case, we do not want to push the virtual environment. So to add a folder, you just write the folder name and then a / after. So like for our case, the virtual environment is named venv. So you'll just type venv and then a / after. So when you are pushing your project to GitHub, Git will see that these will read through the files and folders in gitignore and know that these are not supposed to be pushed to GitHub, so it will be ignored and remain on your local PC or laptop. Don't be pushed to GitHub. Other files that you add in the gitignore file is sensitive files containing sensitive information, like the .env files. .env files is where you store sensitive information like API keys, your database connection strings, what else? Passwords. Yeah, but actually, I don't know if you are to use this, but thank you for creating it. So a .env file, if you create it, it has like a cassetting icon. a gear icon, which basically we are used to it as settings. So that's why we basically store sensitive information, like as I've said, passwords, API keys, connection strings for maybe a SQL database. Yeah. So I can see we are done installing. We are done. The libraries are done installing. I hope everyone is at the same point where we are. Anyone who has Sharon, I can see you've raised your hand. You can ask a question.
Accidental.
Sorry?
No, I don't have a question. I accidentally raised it.
Oh, okay. No worries. Anyone with a question, errors?
Which libraries are you installing?
On the chat.
Check for the
I've shared them on the chat. You can just
Okay, thank you.
welcome. So
manual.
so Mary,
Manual. Manual.
yeah.
Yeah, I'm trying to figure out how to confirm that I have the VENV. Mine isn't listing. It's not listed in the files that I have.
.env.
Yeah, the .env. Though it seems to have created it, or I think it has. Is there any command that I can use to check and confirm that it's actually installed? Mastering.
So you can share your screen. Debug. Yes, you share.
This is the command one.
We install Okay, so look, what was specifically your question?
When I try to run it,
I know
I
most studies
had
they actually have that
Yes, it
A and
is.
B.
Yes.
Just a moment. Yeah, because from my listing here, I don't see it listed among the files that I have under this folder. I had it
The
installed.
virtual environment that you created.
Yes, the virtual environment that I created.
I can see it's
Installed
there.
there.
You've named it Chan, right?
Yeah.
So I think it's the first folder.
Under this.
So I think you've created two folders with the same name. So that you have telco customer Chan and telco customer Chan inside it. So the first folder that you have there is the actual virtual environment, the one that is named Chan. And then telco customer Chan is a repetition of the root folder that you are in that now.
This is a root folder. It's very self a telco customer channel.
But it seems that you have created another that is named the same name. So you are not specifically in the telco customer channel. So you have two folders. There's the first one that is named telco customer channel, right? The one that is like the root now.
Yeah.
Now inside that telco customer channel, you accidentally created another one called telco customer channel. So that's where the confusion is coming from.
Yeah, I'm trying to figure out how that actually happened because it doesn't make sense how. Anyway, how do I revise that now?
So just you see that virtual environment that you have there, you can delete it.
This one here.
Yeah, delete that one. So go to file and then open folder. I want you to open that in almost folder, the telco customer channel now.
From here.
Open folder.
Oh, okay. And
I can't see. I think there's supposed to be another window, but I can't see it.
let me change the sharing format.
Okay.
Okay. So I realize it has two customer channel folders. I don't know how that happened.
So just you can remove it, not remove, rename the outer one. Just rename the outer one to go one step behind.
It's this one.
That's the inner. I think that's the inner one.
It's the outer one.
Really, no, I don't think so. I can see the outer one on the directory. The directories. So that's the inner one.
Just this is the inner one here. It's the one.
Yeah, that's.
Now this is the outer one.
No, still go one step behind.
One step behind, I'll be moving to.
Click that customer channel there that you have the first one.
Confusing me now. So this is it here, the outer one.
Yeah, that's the outer one. Yeah.
Yeah. So I rename this.
I renamed that one to avoid the confusion.
me close VS Code because it's interrupting. Okay. Rename the outer one. So this is the inner one.
Yeah, so you'll use the inner one.
So yeah, now I've renamed the folders out. What do I do next?
So just go back to VS Code and reopen. So open folder, file, open folder. Yeah, so you'll work with that. Select folder. And now we can create another virtual environment. Trust folder and continue. Oh, you forgot to add VENV before naming your virtual environment. So it's Python-M.
It's
-M, VENV, space. Now you can give it a name. Give it a Chan, yeah, like that. I'm sure not all files have been created. So what you'll do, the one that has been created, just and try to create it again. I'm sure as it was creating, maybe something has interrupted it. So that's why you can see keyboard interrupts, and then the error has appeared. So if you try to use it, it might not work like efficiently. So just delete the folder and then recreate it afresh. The Chan folder. The Chan folder, which is like the virtual environment, just delete it. The one after API.
Yeah.
Yeah. I'll try to create it again.
So, saying the keyboard interrupt. Again.
Still, not yet. I think it's still creating the files, the relevant files.
Yeah, yeah.
Yeah, it's now okay. You can now activate it and then activate it and then install the libraries. I think I shared them on the chat.
Yeah. Activating. I just type activate.
No, you write chan, that's the name of your virtual environment, chan,
Yeah.
/. There shouldn't be space, so it's just /.
Yeah. Yes, imagine /.
Scripts. It's very simple script.
Michael, can you mute? I'm getting confused between what you're saying and I'm mixing him up with you, Emmanuel. You said /.
So Joseph, add / scripts, plural, it's a plural, scripts after the /.
Yeah.
But the script is supposed to have a capital S. Then / activate in lowercase. Enter. Yeah, so you know it has been activated if it has that green color before the directory, so it is activated. I need to install the relevant libraries.
Okay, thank you so much.
Okay, so Michael, let's share your screen now.
Am I audible?
Tumia NLB.
Am I audible? Am I audible?
Yeah.
Okay. So let me share my screen. I tried to use AI, then AI kanifanyia hivi, so nilikuwa nashangaa iko sawa. The requirements.txt.
Just zoom in kidogo. I don't know, it's not that visible. Yeah, so you're using Anaconda, right? The base in Anaconda. I think so.
DCG.
Okay, so I think there's Anaconda. Try it, reopen the terminal again. Just reopen the terminal. This PowerShell, no, this is not PowerShell. Oh, you have to make Ubuntu, right?
Yeah.
So to activate virtual environment, you write source space. Yeah, I think it has autofilled for you. Tab. Control C to terminate the process. Control C. Oh, tab now. I think it's activated. Yeah, it's activated. Can I the brackets before the directory? So try to pip -r, pip install -r, then requirements.txt. Install the way it appears there. Enter. I think it's okay.
Thank you so much for the help.
Okay, so anyone else with an error? More they're stuck. Stop sharing your screen. So maybe you can share back the screen. And then you still work on the project. So right, so now you can create a new notebook. I think it won't be created. You have to click that notebooks folder first, so that it will be created inside that folder. So you click there. Yeah. So after it has been highlighted, you can now create a new notebook. You can name it maybe name it project.ipymd, or however you prefer. So hope everyone has been able to create a notebook. You click that notebook folder, then there is a plus sign. There's a file icon with a plus sign. That's why you click. Then you will create a file with an extension of .ipynb. It means interactive Python notebook or something. Yeah. I hope we've been able to do the same. Anyone who is stuck?
Sorry, Michael, were we supposed to create the IP1, IPynb?
Under the notebooks folder. So you need to click that notebooks folder, ensure it has been highlighted, and then you click that file icon with a plus sign. So that's now you can select kernel. So the kernel that we'll be selecting is the virtual environment that we've created. So maybe you can select the kernel.
Sorry, what have you said? I select what?
Kernel, the kernel that we'll be working with. On top right corner, it's where, so yours, you named it VENV, so that's what we'll be using. After that, now I think we can start. So create a markdown cell and then you add to hash sign, and then we'll say step one, import relevant libraries. Import libraries or relevant libraries. So all our importations will be doing at the top, and then you can run control enter.
Excuse me, Michael.
Then our code cell will import pandas as PD. Pandas, for those ones who do not know, it's like the Excel that we use in Python.
Michael.
I think I've had someone talk. Is there any question?
Yeah, there's a question here.
Yep.
It's who's talking, yeah? I'm having a hard time finding the environment. It's very self.
Okay, you can share your screen. My look.
Okay. Yes. Because I'm searching for it here and it's not appearing. It's not listed.
Okay.
Itself.
And there's no refresh button over there.
Refresh where?
Select kernel, where there's select kernel, and then there's supposed to be a refresh icon. Python environments. That it was the refresh. There's a refresh icon on the corner, top right corner. Yeah, there. Click that. Yeah, it has appeared over, like the one that is on the lowest. Yeah.
Okay.
Select.
That's okay. Thanks.
Yeah, just unmute from your end.
Okay. So I am trying to look for my virtual environment. Yeah, but it's not popping up. I've just tried to copy the path, but it's not picking. Yeah, that's the path. So how do I navigate this?
So there is a chain created. It's under telco customer channel.
Yeah, exactly. Yeah.
I would try to open now specifically the telco customer channel folder.
I tried to open here.
No, file, open folder.
Where here? Open.
No, like just open like a new try.
Oh, open a new. Okay.
Yeah, like opening a new project. So
Yeah.
open folder.
Open folder. Do channel.
Open that, double click, then specifically that. Then select folder.
Oh, move into the Nini. Okay.
Yeah. That will be like our roots.
Yeah. Oh, okay. So it was looking for the root. Okay.
We'll try to save it first. What books?
Project.
Yeah. So, select. Private environments.
Oh, okay. So thanks.
No one else with an error. Share screen. Okay. So the issue is link iko tunataka refresh. Uncle, iko sorted. Iko sawa? Okay, so link maybe you can share your screen. Shaq can stop sharing.
Yes.
Mary can share back the screen. Yeah, so the first thing that we've done after you've selected the kernel, we've created the first cell, which is a markdown cell. So we are numbering everything in steps from step 1 to the last step. So the first step that we'll be doing is importing the libraries that we'll be using. We'll import some now and others will be importing as we proceed. So the first library that we're using is pandas. So we are importing pandas as PD. So PD is like an alias for pandas. The next library that we'll be using is NumPy. Import NumPy as NP. NumPy is like an arithmetic, it's for arithmetic operations and mathematical operations. It spans along from simple calculations to complex array-based calculations. Arrays are like matrices, the ones that we did in high school. So NumPy can handle, basically it's good to handle like when you have like really huge arrays. So the next module that we have is can import Matplotlib. Will do some visualization, but it will be briefly, brief EDA or exploratory data analysis. So import matplotlib.pyplot as BLT. And then Seaborn, import Seaborn as SNS. You can now run that cell. Install. So what is being installed is drivers that will support the Jupyter Notebook, communication between Python and the Jupyter Notebook file. So we didn't install it. So VS Code has automatically detected that it's missing. So that's why it has prompted us to install. So let's give it some minutes or seconds, depending on the case. Mhm. Yeah, you can share your screen as we wait for Mary's minute to run. Sure. Select kernel, click there. Yeah, install or enable suggested extensions. That is Python. You need to, after you install VS Code, you need to install a Python extension, your VS Code, to be able to communicate with Python and Jupyter. So that's why you didn't have the options. Anyone else having an error or they're left behind? Yeah, Python environments. Yep. The virtual environment is supposed to be one of the listed environments. Refresh. If it won't appear, just close the VS Code and reopen it again. It will have refreshed. Which error? You didn't install. So pip install. You can just in a new cell, like an exclamation mark, then pip install. So Michael, we'll go to VS Code file on the top. Yeah, actually, I think this will work still. We'll try to open the notebook. I think it's opening, give it time. Okay, let me see. Maybe it run, but you had like an exclamation mark before. I think it's the Omerita Chan, right? It says refresh. Open the manual way instead of using the terminal. Open file where the file is. On the top, at top. Okay, open folder. So. Try. Okay, so Mary, you can share back your screen. Hello. But try to restart your kernel. Maybe it will have refreshed everything. There's a restart button over there. Just along the same tab. This tab and ribbon. Yeah, along the same ribbon, we have restart. Yeah. Mambo mboga hiyo. Abu, try to close VS Code and then reopen it again. Maybe it will work fast. Yeah, it has worked. So the next step is we'll create another markdown cell, step 2. Two hash signs in step 2 is we'll be now loading the data set. Let's give it a variable name cleaned data. Not cleaned, customer data. I don't know where I've got the name clean, but customer data. give it the variable name customer data is equals to pd.read CSV. So depending on the file that you have, is what we'll write. For example, if you have Excel, you will write pd.excel, but for our case is pd.read CSV because our dataset is in CSV format. Pandas can read many types of files. It can read CSV files, it can read Excel files, it can read Parquet files, can read which other file? I think it can read SPSS files. Could be wrong. Can also use pandas to read from a database. But for a case, because our dataset is a CSV file, so we'll say pd.read underscore CSV brackets, and then the directory to your dataset. So we stored the data in the data folder. So right click, copy path. In quotes now, you will paste the path to your dataset. In quotes, paste. Try to run it. Add an R before the quote, the first quote. Try to run it. Yeah. I think the reason for the error is because they are the backslashes. If it was the forward slash, it would have not raised the error. I hope everyone has been able to load their data. Kosawa? Kosawa? What about the rest? All right. So after we load the data, we need to confirm if what we've loaded is actually what we are working with. So we'll read like the first 5 rows. So we use a .head method to read the first 5 rows in a data set. So I'll say customer underscore data .head. Then brackets, because it's a method, run. So that's how our data set looks like. We have customer ID, gender, senior citizen, partner, dependents, tenure, phone service, multiple lines. Can scroll to the right. So there are some columns that have been hidden. So for every column to be displayed, we'll add something up where we are importing libraries. Create a blank line and then create another blank line up, separate it from the actual libraries. So we'll say pd dot set option, set option, set option, then brackets, then in quotes we'll write set display dot marks underscore columns. Wait, who's that genius? Marks underscore columns and then comma none. If you add none data type, it will None is a data type in Python. For those ones who did who have covered Python. No, it's out. The none should be outside the quotes. So if you add none, it will display all the columns that you have. Tab. But you can also set the number of columns that you want to be displayed. So instead of none, you can have 2, you can have 3, depending on the number that you want to be displayed. So you can run that cell. So to run, use that play button. Now we can be able to see all our columns. Yeah, so we've confirmed that our data set is actually what we wanted to work with. And so we go to the next step, which is step 3. The next step is, sorry?
Can I see the code that you've used for the display?
Okay, Mary can just scroll to the top.
I seem to have the same thing, but I don't understand what it is. It's giving me a name error.
You can share your screen. Just share your screen.
Just a moment. I think is there. Yeah. It's mine was the none had written with a lowercase. So.
Oh, okay. Mary, you can share back your screen. So the next step is step 3. Step 3 is we want to do I call it pre-cleaning EDA. So I want us to look at how the data set looks like, in the sense of we want to see how are the nulls, do we have any missing values, how are the column names written, what else? The information, basic overview, how the data types are written. Are they in the intended data types, or for example, mostly it's dates. When reading using pandas, dates sometimes, instead of coming as in form of dates, they come in form of object or string. So you need to do like a pre-cleaning EDA, just see how your data set looks like. So use double hashes. The single hash is to yeah, like that. So we'll do everything at a go. So we'll create like a function that will check everything at once. So you just we define a function. So define a function, call it basic checks or something. Yeah. Write it in snake case. So the B is supposed to be lowercase. Basic underscore checks, then brackets, The parameters that we'll use is just the data set. So write data or df. And then close now the function using a colon. Now, the first check we can do is you can check for the shape of the data set. So print and then data dot in brackets data dot shape. So shape is an attribute, so you won't add any brackets after. Then the next thing you can check is duplicates. Just create another print statement. So what a Python function is just a reusable piece of code. So for duplicates, call it duplicates, then in quotes. Then say data.duplicated.sum. Not like that. I wanted you to like give it a name, duplicates in quotes, then comma. So data, I think you can remove also those brackets. So data.duplicated brackets dot sum. Brackets. Next thing you can check for is let's check also for the column that we have. So data.columns. .columns, it's also an attribute, so that's why we are not using brackets after. Another check is you can now go to the data types. So print. I want to see what are the data types of each column. Have they been read in the preferred data types form? So I'll write print, then data.d types. Data.d types. Next is missing values. So it will be data dot is null, or you can use is null. Is null brackets dot is dot sum brackets. Next, can have see what you can use. You can check for next. You have checked for missing values. You can also check for a statistical summary. So print data.describe brackets, and then we'll add dot capital T after to transpose. That's for numerical values. For categorical columns, you'll still write the same, but inside the brackets now, you say include is equals to print data.describe brackets, then include, just in between those brackets, the green brackets, include is equals to square brackets, in quotes, anything that is string, str, outside the quotes, comma, and anything that is object. You have added a space, so object. And then after the green, you can transpose also. So after the green bracket, add dot capital T. We are transposing. I'll show you what it does. I think these ones are enough for the basic checks. So we can run it. So to call that function, we say basic checks, basic underscore checks, brackets. Now, it's a function. So in brackets, to call that function, we'll pass our data set as a parameter. So we'll write the name of our data sets. Now it was customer data. We'll pass it as a parameter. No, as an argument. Parameter is what we named when we were creating a function. So for the shape, you can see the shape of our data set is, we have 7,000 columns, 7,000, not columns, 7,043 rows and 21 columns. We have 0 duplicates. Those are the columns that we have. The data types, we have strings, customer ID is a string, gender is a string, senior citizen is an integer, partner string, dependent string, tenure string, on service string. I'm looking to see if there's a scroll, just scroll down. Then click that scrollable element to display everything. And I'll scroll to just scroll chini sasa slowly. Total charges, you can see where total charges is. Scroll kidogo. So total charges is supposed to be a number. It's supposed to be number, but you can see it has been read as strings. So this tells us that we are supposed to convert total charges to actual numbers. Because strings are, these are letters, symbols. So the first thing that we'll act on is the total charges when we'll be doing now the cleaning. For the missing values, scroll. You can see the ones that I can see over here, there are no missing values. Yes, it's clean. And this is a statistical summary. So the issue with the way it has been displayed, it's not like easily readable. So I want you to do this. Where there was where we added where the function is, where we added the statistical summary dot describe. So kutoka where data is to t, I want you to put it in brackets. From where data is to t. So we want it to be inside a method called describe. Not describe, display, sorry. A display method. So if you use a print statement to something that is supposed to be displayed in as a data frame, the way it is displayed is somehow illegible or hard to interpret. So we add a display method. So write display. Same for the other one. For the first describe. So write describe or display run. Run also where we call the function. Can now scroll. So you can see it now looks better. So for the numerical statistical summary, it tells us a few. It gives us a few information about the dataset. Like first, it gives us information about what, like the mean or the average in that specific column. We have the standard deviation. We have the minimum. What's the minimum value? We have 25%, or can call it lower quartile. 50% is the median or the middlemost. Then we have the maximum. We also have the count. And then for the categorical data doesn't have a lot of descriptive statistics. So it's mostly the frequency, the mode or the most appearing, which is, for example, for gender, the most appearing is the male gender, appearing 3,555 times. We have unique. Unique is the number of categories that you have. So we have 2 unique categories. Yeah, and then the count is 7,043, which is the size of the data set. So I think that's it on the basic checks. So we've seen that we need to transform one of the columns to, which is total charges, to from a string data type to a float or an integer type. And so the next step will be data cleaning now. Okay, the data set is not like really dirty. So what we'll be doing is just data cleaning. A simple cleaning where we will cast that column to numeric. So this was step 4. So the first thing that we'll do is, it's recommended to unify, like to unify the name of all the names of your columns have been written to, for example, lowercase. Mostly we use lowercase. We set the column names all to be lowercase, and also we try to strip all any possible trailing or preceding spaces, because if your column name was, for example, written with a trailing or preceding space, it might raise an error, which would be a headache to actually trace it. Because, for example, if you have the column name like contract, then maybe by accident, the one who was entering that data, they entered contract and then a space. But for you, you can't see like a space, the space after or before. So you might have a tough time when it comes to correcting that specific error, which is emanating from maybe a space that you didn't see. So to avoid such errors, we first like try to unify everything by removing any preceding or trailing spaces, and then you set everything to a lowercase. So that's what we'll do. To do the same, I want you to inside that Abu, open the markdown, that step 4 markdown cell, double click it. I want us to subdivide it again. Yeah. Just to make everything uniform. Yeah, a mixture. Not really, just to make everything uniform. And mostly it's like a standard practice. So in a new line, Mary, use how many underscores? I want you to type 2 underscores. Then we want to write standardized column names to lowercase. Lowercase, and then comma, remove any preceding or trailing spaces. And remove any preceding or trailing spaces. Preceding with it's E, not I. So preceding or trailing spaces. Then we close with 2 underscores. We want to bold. Yep. Can run the cell. Right, so now to do the same, we'll say customer underscore data dot columns is equals to customer underscore data dot columns then you'll write dot as type as type brackets string str No, it's not supposed to be in quotes. Kwa sawa tukiandika STF. Then .str. Then, so what we've done, we have casted this everything into string. So if there was any column name that was maybe integer or object, it has been converted to string. So we first convert it to string, then write .string .str, then .strip, that is to strip any preceding or trailing spaces, brackets, .str tena, .str then .lower, set everything to lowercase. Brackets, it's a method. Yeah, so you can run. After that, you can check if the changes have been implemented by running the .head. So customer data.head. Yeah, so everything is uniform. The column names, you can see there are some which had a mixture of uppercase, lowercase. Now they are uniform, and in case there was any spaces before or after, they've been removed. So that's the first step. Because the data set is not like really huge, dirty. So the next thing that we're supposed to do in cleaning is to typecast now the monthly charges total charges from string to float, because I think they have decimals. Yeah, they have decimals. So we are converting them from a string data type to float or decimal. So add another markdown on top of that one. Tutarudi kutumia hiyo. Then using bold, we just say typecast total charges to bold it by using, you can use actually 2 asterisks, or you can also use 2 underscores, the way we did previously. So the reason why we are using these markdowns is if you give someone else these projects, they can be able to easily follow through your work without struggling to know which step am I, what have you like specifically done there. So write typecasting, or just write convert total charges from from string data type to floats, because I can see they have decimals. So try this customer data. Then that specific column, which was total charges. And we'll look at how it has been written. Check, just confirm how it has been written. Yes, we can just copy the it's written there. Total charges. So we are doing the operation on that specific column. So we write square brackets in quotes that column name. Yeah, in quotes is equals to customer underscore data, then total charges. And the way you've done it, then you just add dot as type float. I hope everyone is following through. And if you have an error or you'll be left behind, you can just raise your hand. Then brackets float. Michael. You can run that, can run the cell. So you have an error. So the reason why there is an error is probably there is a space that, so a space, sometimes Python might treat a space like a form of data. So it won't be null. That's why under missing values, we didn't see any missing values under total charges. So probably someone left a space instead of a blank. So you can see, could not convert string to float. Then in quotes, there's a space. So that's why there's that error. So an alternative to this, so this is one of the ways you can comment it out. This is one of the ways to typecast. But if it doesn't work, alternatively, now you can say customer data, total charges, highlight that specific cell, not cell, column, I mean, customer underscore data, square brackets, so write total charges, because we are doing the operation on that specific column. In quotes, put it in quotes. Is equals to now we'll write pd dot to underscore numeric. PD for pandas, PD dot to underscore numeric, to underscore numeric. No, like to write to underscore numeric. Not two for the number, it's two to somewhere. Yeah. PD dot to numeric underscore numeric. I think it's there. Yeah, to numeric. Then brackets. Let's say customer underscore data. Inside the brackets, that is. Then select a specific column, which is total charges. So square brackets, then total charges. And just press tab because I can see it as yeah. Then quotes add errors is equals to coerce. The way I think it's Copilot as inside the brackets, the normal bracket supposed to be inside. Comma, then errors is equals to coerce in quotes. Errors is equals to coerce. Coerce is supposed to be in quotes. You can run it. So errors is equal to coerce. What it does, if there's something that there's maybe something that doesn't conform to the majority data types, which majority are actually integers or in numeric form, but now there is a case of a space or maybe a letter. So what errors is equal to coerce does, so instead of raising an error, errors is equal to coerce will set everything that is not within the majority amongst the majority to none, and then the code will run completely. Like it will, so we'll have some nulls or missing values. Everything that doesn't conform to that majority, which is numeric values, will be casted to missing values or none, NaN, or a blank, basically. So if you write missing the a.snarl.sum to check for missing values, you'll see now that we have some missing values. .snarl brackets, not there, a new line. We are checking for missing values. We are done with that. And so that's it for Mary to. You need to write clean data.isnal.sum because we are checking for missing values are fresh. Customer data, just like customer data. I don't know why I'm keeping on saying clean. Then .sum. Write .sum to give you like now an actual overview of the missing value summary. So under total charges, we have 11 missing values. So those were the ones that were missing, or they were written in form of actual strings and caused everything to be read as a string. Okay, so since I think we do not have anything else to clean, we will go direct to now dealing with the missing values. There are various ways to deal with missing values. I can create a new markdown in bold to write cleaning the missing values or nulls. No, it's still under data cleaning, Mary. So I'll just write it in bold. So you write it the way you've written underscores, using underscores. Yeah, like that. So when it comes to missing values, there are various ways to deal with them. But it's dependent on how many missing values do you have. So if you have missing values above 35% of your data set, you're supposed to drop that whole column, because filling that column will be diluting the actual message of that data set. Like you will distort the data sets. So everything that will be there will that 35 or and above percent will highly influence what actually was there. So you better drop the whole column. But if you have, for example, 34 and below, you can fill the missing values using either mean or the median. But the mean, use the mean sparingly, only if your data is normally distributed. Mostly just use the median. The median is not influenced by outliers like the mean. And when I say outliers are they are data points that do not fall where majority fall. And I always give an example of, say, a university. Think of a university setting where we have students, and the students, if you look at where the majority fall within, it's between, say, 16 or 17 to around 40. So don't say 40. But that doesn't mean that the university doesn't have students who are 70 years old, probably pursuing masters or PhD. So a 70-year-old will be an outlier in that case. So that's what we are referring to, outliers. So mean is highly influenced by outliers, either above or below. So to avoid using mean, which can be corrupted, just use the median. Median isn't highly influenced by outliers. And then if you have nulls or missing values of 5% of missing values or below of your total data set, you can drop the actual rows. You can drop them, or you still have the option to fill them. I think I have highlighted for the case of numerical, but when you have a case of categorical values and still falls within that threshold of 4% and below, you can fill it with the mode. Mode meaning the most appearing value in your data set. So, so categorical values, they have only one. I can say they have only one. A measure of central tendency, which is mode. So you can't calculate mean for categories or median. So we mostly use the mode, which is the most appearing. So since we can't use the mean or the median for categorical values, we use the mode. So if it falls within those threshold, you have that 5% and below missing values, unaweza fill na the mode. Yeah. Kwa sawa?
In the case that it's not say it has a divided percent and above the missing values, and it's an important category that we end up dropping that all night, and it's not what we need to use to compare.
If you have if it's important and then you have more than that 5%, I think you can try to feel it. Okay, see, there is like a fixed universal way of doing it, but mostly that's what we follow. If it's really, really important, you can try to feel it. But if you feel it, and then, for example, you had two classes, you had yes or no, right? If you feel, say maybe the majority was no, and then if you feel it, yes becomes the majority. So it has distorted what was actually there. So you don't have any other option. No, you have to drop it. But if you feel, and then it supplements what was already there, you can still proceed.
For the customers,
Mhm.
maybe what can tech support is important. So kulikuwa na kati ya the type of service provider they use.
Mhm.
So upate hiyo column haina majority. Like a majority ziko na error.
How, like
Like the error is 35% and above.
missing values.
Right,
So this is how you know the majority. If you want to know the majority, you use value counts. It will tell you the number of. You can also plot. The graphs will show you which is the majority, but the majorities will never miss, unless if there is a tie, which is a very rare phenomenon. But still, I think you can give it like a leeway, but it should not exceed 50%. Yeah. It's not, if you have really to fill them, just don't exceed 50%. But mostly use that 5%. Then 50% is when you really, really have to use that column. If anyone with a question from online or physical also, if you have a question on missing values. So we are all okay. Can give me a thumbs up, come on, sawa online. Yeah, so I can see a number of you are sawa, but if you still have a question, you can just raise your hand and we'll respond. So I want us to see what is the percentage of nulls do we have in our data sets, or what is the proportion? Do we have the option to drop or to fill? So you can see we have how many nulls? 11, right? So just say 11 divided by the total number of rows. Yeah, you can say 11 over len, the length of your data set, divided by len. It's // the divide is // not backslash. Yeah, / len brackets, then the name of your data set. Len is it's also a list method. Yeah, you can also multiply by 100. Put everything in brackets, because if you run it like that, it will multiply only the len by 100. Use BODMAS or PEDMAS. So you'll add from 11. Mary, just add everything now into a bracket. from 11 to the other closing bracket. Yeah, so now times 100 to convert everything to percentage. So can see it's only 0.15% of missing value. So we have, since it's less than 5%, we can drop the analysis. So to drop these, I say customer underscore data, then select a specific column, square brackets in quotes, the column name. Is equals to is equals to customer data target, not target, total charges So you'll also have to specify the data set. So right before that square brackets, customer data, and then you'll write dot drop na. After total charges, dot drop na, then because it's a method, you can brackets, can add brackets. We'll try to run. Check if the missing values have been dropped. Confirm by using isnal.sum. Isnal, it's a method, so brackets then dot sum brackets. What do we call? Alternatively, just scroll to. So just write customer data is equals to, so remove the total charges. If that hasn't worked, I think can have an alternative to that. Remove that, and then still say remove the second, yeah. And then inside the drop na, you'll write subset is equals to. Then in square brackets, that specific column name. Quotes, then total charge. It has worked. Subset square brackets. then that column name in quotes. Toll charges. I think they're not separated.
Oh. Okay.
Mm.
Okay, subset.
Subset, like it's then, yeah, that's where you're specifying the columns, which columns that we want to drop missing values.
Oh, okay.
So there's something we didn't check. We didn't check how each category has been written. So I want us to we'll create like a filter out. So we'll first filter out and remain with columns, categorical columns. So say cut columns, create a variable named cut columns or categorical columns. Is equals to now cleaned data, not cleaned, customer data. Dot select underscore d types and then in brackets include is equals to include is equals to now in square brackets we'll write we want anything that is a string and anything that is an object. Comma quotes object. So what we've done, we have filtered out and remained. You've only remained with columns that are categorical. Dataset, your dataset, which is now filtered under categorical columns, only contains categorical columns. But for us, we want you can just say cut columns.head. Ndio muone. So it's a subset of only the categories. Yeah, so, but for us, we wanted the column name. So what we'll do, after the select d types and then include is equals to strings and objects, you'll add dot columns and then dot to list. Hapo juu tu kabisa, like where we've written where we've created the categorical columns subset. So you'll write dot columns, just a continuation of what, yeah. So dot columns, dot to list, it's a method, so brackets, run. So remove the dot head because it's now a list. We've only remained with the column names. Yeah, so you can see we have the categorical columns. I feel like also the senior is a category, supposed to be categorical, only that it's written in number 0, 1, 0 of no, and 1 for yes. Okay, let's do this. Just use what we have. So we'll create a loop, and it will be showing us how each category has been written. So we'll say for create a loop for column in, or if you want to use the uh, list comprehension, can also use it. So because what we want is specifically the actual categories. So you'll say customer data, then column. Let's try this customer data column for column in categorical columns. I don't know if this will work. So Mary, just write the log loop, the long for loop. So write for column in, for call or column in categorical columns. For column in categorical columns, I think it was columns, right? In cut columns, we want to print. Now close for the indentation purposes. Print brackets, then cleaned, not cleaned, customer data brackets call. Square brackets for each column, because we are looping through each of the columns. Column, now we want to get the specific entries, so we'll write dot unique. Dot unique. It's supposed to be inside the print statement. Sure. Yeah, dot unique. Brackets, it's a method. Run. So I don't know if we can tell which belongs where. So we can add another print statement above that. Just scroll back to the code. Above that print statement, not a new cell. I wanted just us to append that code. So there, print. Can write print brackets. I want you to, in quotes, add the like minus sign. How many hyphen? Yeah, minus sign. Then multiply it by 40 outside now the quote. Multiply by 40, comma, column, call, write call, comma, then in quotes again, hyphen times 40. is for us to be to easily know where does each belong to. Each of the category, where does it belong? Run. You can run the cell, Mary. Yes. Now you can see, you can easily tell where does it. Times 40, we are multiplying that, remove the comma after. Yeah, Musha. Yeah. Yeah. Run, I. Yeah. So you can see now, you can tell. Yeah, which column does the categories fall under? So we've multiplied that minus sign, a hyphen sign, 40 times. So that's why it's giving that pattern. Yep. So under gender, we have female, male, partner, yes or no. Just ignore the custom ID because you drop it anyway. Then partner, yes or no, dependence, yes or no. Just scroll through and analyze one if there's anything that is written in click that scrollable element so that we can see everything. Yeah, so scroll through and look for any inconsistent column or any category that looks like it is repeating itself. So the reason why I'm supposed to do this is sometimes you might have this categories that mean the same thing, but they've been written in a different way. So an example is, assume we have a column like city. If you have a column like city, and maybe in the survey, the data was collected through a survey, then there's someone who wrote, for example, Nairobi, wrote Nairobi as Nairobi. Someone else wrote it as Kanairo. Someone else wrote it as NBO. Someone else wrote it as NRBI. So what basically you are doing is confirming if there are columns that are redundant or not. Since they are all delivering the same message, they mean the same thing. If you encounter such a scenario, you rename them to have one single name that represents all the different namings. So it's really important to check how your categories have been written. But for a case, I can see they are okay. I think we can now go to EDA. We'll do just a very short EDA. So that's the next step, which is step 5. So that's what we did before, was pre-cleaning EDA. So the next step is post-cleaning EDA. Post-cleaning EDA. Now, we know that we are handling a classification problem. We need to know how are our classes distributed, that is the yes and the no. So the distribution is really important so that first we know which type of evaluation metric we'll use when we'll be evaluating the model performance. 2 is what maybe stratification methods that we'll use, or will we use stratification methods? Stratification is where you want everything to be represented equally as the way the original data set is during the step of splitting the data into train and tests. Yeah, so we can visualize the target, which is Chan. I think it's Chan, yeah. So to visualize, we'll use matplotlib and Seaborn. So just add a comment hapo useme visualizing the target, the distribution of the target column. So first, write plt dot figure. We want to set this the figure size of our visual. So in brackets, fig size is equals to in a brackets you can set maybe 10 by 5, 10 by 7. That is the length and the width. 10 by 7. After that, now we'll use Seaborn's count plot. So we'll say sns.countplot. All right. So sns.countplot. So data we are using clean data. So data is equals to clean data. Clean. I think it's gonna something about clean data. Customer data. And then comma, x-axis now. We are visualizing x is equals to Chan in quotes. I think that's the column. X is equals to Chan. I think that's it. Then we can add a title, plt.title. Title, brackets, then in quotes can say distribution of classes. Classes in the target column. And then you can also label the x-axis using plt.x label. So the x-axis is in quotes, right, Chan, which is the column. The y-axis is the count, so plt.count .y label, then count. Why label? Yeah. Why label? I think there's a typo. And then plt.show to print the final plt.show. Run. So based off the visualization, you can see that our classes are imbalanced. That is, we have the majority being no. So majority are the ones who will keep using the services. Services of the telecommunication company, only a few that will churn. Yeah, so I think that's it on the idea. Due to I think time is really gone, so we won't do any further idea. If you'd like to do ADA to learn more about what the data is, how classes have been distributed, I think you'll do it later at your own time. So for now, I think we should go for a break, a 30 minutes break. Then we'll come back and now do the machine learning part. We'll train the models, and then hopefully by 4 we'll deploy. So let's go for a 30 minutes break and we'll be back. All right, so I think we can now proceed after spending 30 African minutes for a break. So, Mary, you can just share your screen back. Mary, you can share your screen so that we can proceed. So, the next step that we'll be doing, we'll be splitting the data sets into train and tests. So that's step 516. Step 6. Yeah, split to train and test. No, yeah, split into train and test, and also split features and the target. Command, we're also splitting the features or the predictors and the target. So we'll give the features the variable name X, capital X. And the reason why we use a capital letter is because it's a two-dimensional array. So a two-dimensional array is an array that has more than one columns and rows. So it's not like 1 times 3 or 3 times 1. It's above. There's no one, like for the rows you have above 1, for the columns you have more than 1. So features is equals to, no, you're supposed to say X, which represents the features. I was just explaining why X is capital X. So X is equals to customer data dot drop, and what we are dropping, we are dropping in brackets, then we'll say not square brackets, normal brackets, it's a method there. Then columns is equals to square brackets. Then the first column that we are dropping is the customer ID. Customer ID doesn't have any predictive advantage, so it's just an identifier of that specific customer. That it doesn't basically influence if someone does anything, or for example, it doesn't influence if someone will churn or not, because that's just the identifier. The other column that we are dropping is the target column, what we are predicting, which is churn. In quotes, churn. Let me see if there's another column that we are supposed to drop. Then in a new line, let's now define the target. The target is what we are training the model to be able to to predict after we train the model. So y is equals to I will just say customer data. Then we are selecting the chunk, which is the target. Square brackets. Chan. Yeah, so you can run it, run that cell. So just add upon while you added the step, just add a bold line just to specify what you've done there. In a new line, in a bold, write that is underscore. You write splitting the features and the tag from the target from the features. Yeah, so that will be more clear for someone who will be going through the work. And then in a new markdown, now we are splitting into train and test. Train is what we'll be using to train the model. Test is what we'll be using to evaluate the model if the model has actually performed. Splitting into train and test like that. Now, we want to import the library or the function that we use to do the splitting. And the function is train test split. So you'll go, Mali, we were importing, then say from a scalan dot, I think model selection. From a scalan dot model selection, import train test split. Model underscore selection. Import train underscore test underscore split. So as a standard practice, you'll go and import it. We could do step 1. So convert that cell to Python. Escape, and then you could just Control Z to undo. Escape. Y. Press Y. Y. Just click Y. Letter Y. Equivalent. Supposed to change. Yeah, supposed to change from Markdown to code. So just give me a second. I'll be back. All right, so after splitting, after importing the train test split, maybe you can paste it to Koju. I think you already did that. Yeah, you can just remove that. So we'll now say X train, capital X, X underscore train, comma, X underscore test, comma, Y underscore train, comma, Y underscore test is equals to train test split, the way you imported train underscore test split, brackets. We are splitting X, which are the predictors. So write X, comma, Y, and then test size, comma, then test underscore size. Is equals to, you can use 0.2, 0.3. So what this is you are stating the size of from your old data set. Which proportion are you using for testing? So that means if you state 0.2, 20% of your data set will be used to test your model, the performance of the model. So it will be the test set. Then the rest of the data, which is 80%, will be the train set. So test size is equal to 0.2, comma, then random state. So we are randomizing the selection of the rows. So to avoid the splits, making the model to select like from a specific point where there could be only data points that are similar, you add random states for it to be able to pick random rows for the test size. So it can pick from top, then the next it will pick from the bottom to the middle. This for the model to be able to generalize from the data and avoid that bias of picking from a specific region. So random state is equals to 42. 42 is like the seed, more of a starting point. But 42 is the most used number. Doesn't mean you can't use another number. 42, comma, and then because the data set is imbalanced, we'll add something. We'll add stratify is equals to Y. Stratify is equals to Y. So stratification is where, for example, we have our data set imbalanced in the ratio, for example, of 70 to 30, where yes is 70, no is 70, and yes is 30. So stratification, if you say stratify is equals to Y, stratification picks, you see the same proportion it has on the original data set is what will be transferred to the train and test. If you do not add stratify is equal to Y, it might cause bias. Maybe train might have more number, larger proportion, or a larger ratio as compared to the test. So this is to transfer classes the way they were already distributed. I don't know if that makes sense. Yeah, if you have a ratio of if your data set is distributed in the ratio of I think you didn't run the Nini. Try to rerun from because where you imported it. It's not okay. So the data set is split.
Ask
Mhm.
why
Mhm.
should it be caps or lowercase?
Lowercase because it's one dimension. One dimension meaning it's one column. Yeah, so it's lowercase.
And then the X caps.
Yeah, it's caps because it's two dimension. It's more than one dimension. So to demonstrate what one dimension, two dimension is, answer na x dot head and y dot head. In a new cell to x dot head, y dot head. Not the same cell, Mary. Just use another cell. We are doing just a demo. Or actually, instead of dot head, use dot shape. So remove the brackets also because it's an attribute. Dot shape, dot shape. Add a print statement. So that's why not print your app. Add print statement to both of them so that they'll be printed. There's someone who's getting an error. We'll come back to Bernard just a sec. Print.
Okay.
So you can see X has more than one rows. So you can see the X has 7032 is the number of rows. And then 19 is number of columns. So 7032 is more than one, right? And also 19 is more than one. So that makes it to be a two-dimensional array. And then for the Y, we have 7032, nothing else. So that makes it a one-dimensional array. I hope that answers your question. Bado. So, so unajua matrices, right? So a matrix yenye iko na 1 times 3 itakuwa
1 times 3.
uh-huh. Iko na uh-huh. So here ni 2 dimension or ni 1 dimension. Think of matrix.
That's one.
Now kama matrix ni 2 times 2 ama 3 times 3.
Kama ni 2 times 2.
Na pia 3 times 3 and kupanda. That's what basically we are saying. So X is equal to columns mean. Na rows mingi. So what makes it a 2D array ni juu iko na many columns na many rows. It's more than one. But hii ingine iko na many rows but a single. Exactly. That's what we're saying. So X is independent variable. Y is dependent. Yeah, and not because it's one, it's because the outcome of Y is depending on what X is. Yeah. So that's why we are using X, Y, and for the size, we are using now capital or lowercase. Any other question? Oh, Bernard had an error. Can you share your screen short briefly, Bernard?
Sorry, I already fixed it.
Okay, sir. Oh, we had lost connectivity from our end, but I think we are now good. Yeah, so I think we can now proceed. So the next step will be doing encoding. But we'll encode only the target column. The rest will be done using the pipelines. So to encode the target, so for those ones who don't know what encoding is so that's step 4, just straight step 4, not 4, step 7, pre-processing. And pre-processing, so in brackets, encoding, scaling, those zote. Encoding, have scaling. I think that's all for the pre-processing. See me in commercial. Okay, so I want you to import label encoder. So for those who don't know what encoding is where we transform categories, strings, objects into numbers. Machine learning algorithms or computers in general can't process raw text or interpret it. So we need to give them, to put them in numerical form. So that's what we are calling encoding. There are various ways we do encoding. There's label encoding, there's one-hot encoding, there's ordinal encoding. So each of the encoder has a use case. For example, label encoder is best suited for target columns. Ordinal encoding is best used for when you have categories that have ordinality or follow a specific order. An example is, for example, the education. We have education, one has to come from primary, high school, bachelor's, master's, PhD. So because they have that specific ordinality, can use the ordinal encoder. Then there is a one-hot encoder, which now makes each category like a new column. So I want you to import label encoder by saying from a sklearn dot pre-processing import label encoder. It's a class, so you'll write in camel case label encoder. Can just also add one-hot encoder. We'll use it for the features. One-hot encoder. One-hot encoder. Add also standard scaler. What standard scaler does, it scales numbers, numerical columns to a confined range or scale. So since tumesema computers understand numbers, right? So if computers understand numbers, they have a tendency to be biased towards the larger numbers. So for example, we have a column like salary and a column, you have a column like salary and a column like age. The largest number of when it comes to age that you can have is maybe 70 using Kenya's life expectancy rate. But for salary, you can have even 1 million. So if you train using the raw numbers it is, the model will be biased towards the larger numbers which are under salary. So to avoid that, we scale, and by scaling, we are putting all the numbers into a more comparable range. So that's what scaling is. And now to differentiate encoding and scaling, encoding is for categorical columns and scaling is for numerical columns. I hope you've understood the difference between the two. Next, we can that's encoding and scaling. Encoding, we've said it's for categorical columns, and we've said that we do encoding to convert categories into numbers that computer will understand, or machine learning algorithms. Then scaling is we are putting numbers into a comparable range to avoid bias towards larger numbers. So you can run that cell. Then we have now we'll instantiate that scaling, not scaling, encoding, the label encoder. So add a bold line, say encoding the target column, just to differentiate what we are doing. Encoding the target. So we'll instantiate the encoder by, we give it a variable name like LE. See, it's a label encoder. So we'll say LE is equals to label encoder. The way now you've imported it, capital L, label, yeah, like that, then bracket. Okay, so you've instantiated the encoder. Now it's time to encode. So the first to encode will be the white train. So we'll give now white train a new variable name, white train encoded. White train, underscore train encoded. Underscore encoded is equals to LE, now the name of the encoder, dot fit underscore transform, fit transform. And then the column that we are encoding, which is white train. Brackets white train after fit transform. Y underscore train. Next, we have, now we encode the test set also. So for test set, we won't fit transform, we'll transform only. If you fit transform both of them, there will be a data leakage. Data leakage, think of it as how exam leakage works. So the train will see, as you train the model using the train set, it will have seen the answers from the test set, and we do not want that. So this case, we do not fit transform, we only transform. So we'll give it a variable name, y_test, and encoded is equals to y_test encoded is equals to le dot transform now dot transform. And we are transforming the y_test. y_test. Yeah, you can run the cell now. So create a new markdown cell. Yeah, then add 2 hash signs. So we are building preprocessing pipelines. Add 3 hashes. Go kuliko the step 7. Yeah, building preprocessing pipeline. So the preprocessing pipeline, what it does everything at a go. Instead of going to encode the features individually and scaling individually, you create like a single pipeline that will do everything at once. And also it simplifies, it eases when it comes to making predictions and deploying, because it will retain the same pipeline that the same steps that it has, because it has internalized them as compared to you doing things manually. And so the first still under on that cell can just add now for or use bolds for now we are building a pipeline for the categorical columns. Yeah, can run now. All right, so the first thing that we'll do, we'll first filter out and remain with the categorical columns. Same way we did. So we'll just create a variable name, say categorical columns. Categorical columns. Categorical columns. Define it again. Yeah, just define it differently. Okay. So the reason why we are defining again is because there are some columns we dropped. Yeah. And so this is more of filtered version of it. So just same thing, but now we'll use xtrain as our data set. So we'll say xtrain dot select d types dot select d types include brackets include is equals to include is equals to square brackets. We wanted everything that is a string, everything that is an object. Then dot columns dot to list. No, outside the normal bracket now. Dot columns dot to list brackets. So Abu print the categorical columns. I want to see something. We have gender, partner, dependents, phone service, multiple lines, internet service, online backup, device protection, tech support, streaming TV, streaming movies. Yeah. So there's a column that's supposed to be there, but it is, I think it is in numerical. So, we will add it here by using the list method. Is it .append? So before the print statement, create another line. So you'll say categorical columns dot append, then brackets. We want to add something. There's that column here, senior citizens or something. I will look for how exactly it is written. You write it there. Yeah, that one, senior citizen. The responses on that is 0 and 1. So 0 means no, 1 means yes. Pandas has interpreted it as category, as a number, sorry, but it's supposed to be a category. It's a discrete number. So in quotes, just copy the name, that column name there. Can run it. I think it's supposed to be added to commercial at the end of the list as the last element. Yeah. So we'll now create the categorical columns pipeline by give it the variable name cat underscore pipeline. Is equals to. So I want us to import the pipeline. So scroll Koju kabisa. And I want you to import this from sklearn dot pipeline. Import pipeline. It's a class, so camel case pipeline. And then from sklearn dot compose, import column transformer. I'll explain to you shortly what column transformer does. Yes, so you can scroll down, we proceed. So categorical pipelines is equals to pipeline, that one, yeah, pipeline brackets, then square brackets, then normal brackets again, in quotes encoder, then outside the quote, comma, then one hot encoder is what we'll be using. Right one hot encoder, that one. Brackets. Yeah, just over Malik or two. No, after the one hot encoder, it's not supposed to be in quotes. I just wanted you to add brackets after one hot encoder. Brackets. And then you'll add something, which is handle underscore unknown is equals to ignore. Handle is equals to, in quotes, ignore. So what this does is, for example, you've trained your model using, okay, let's use the old cities that we knew in Kenya, which were Mombasa, Nairobi, Kisumu. But now there are new cities that we have, and you've already trained your model. So what handle unknown does is, if someone predicts using the new cities, that is Eldoret and Nakuru, instead of the model raising an error, ikisema haijui that space, it was not trained on that, it will ignore that, but it will make a prediction, although it will not be the most accurate prediction, but these will make the model to avoid that raising an error. So basically, handle unknown helps in avoiding errors in case of new categories being used. So handle unknown is equals to ignore. You can run. So you can, using that pipeline, you can also use it to fill your nulls, but I don't encourage that. Just clean your data before creating your pipeline. Then the next step is the numerical pipeline. So another markdown when you're building a numerical pipeline. Run. So for this one, we'll name it num or number numerical pipeline. So NUM pipeline is equals to still pipeline then normal brackets, square brackets, normal brackets again, and then in quotes, scalar. close the quote, comma, then standard scalar. So it's not supposed to be like that. Naona iko in Markdown, just escape then Y to convert it to code cell. Y, press Y. I change. Okay. Now we can write standard scalar. Set a scalar, then brackets. Can remove that space that is there. Run. So we've created the pre-processing that we want for each categorical and numerical columns. So the next step is we are now combining the two pre-processing steps. So we combine them using the column transformer. So in Markdown, just say combining the numerical and categorical pipelines. So to combine them, we'll use the column transformer. So we'll give it the variable name preprocessor, which is a combination of preprocessing of the categorical and numerical columns. So preprocessor is equals to column transformer, it's a class. Change that cell to code. Column transformer, yeah, that one. And then quotes, not quotes, brackets. Transformers is equals to if I call quotes by the remove the quotes. Yeah, it's not supposed to be in quotes. Then actually create a new line sasa. Vile tu ulikuwa umeitengeneza. No, still inside the brackets. Yeah, so square brackets. Square bracket, then normal brackets. So we'll say in quotes num, N-U-M. So this will tell a scale, and these are numerical columns. Outside the quotes, comma, numerical pipeline, num pipeline, the one that we created up or Ju, that variable name, yeah, num pipeline, comma, and the columns that we are doing the transformation, actually, we haven't filtered out the numerical columns. So I think we've skipped that step. So tufanye hivi, hapo kwa before the calling the numerical pipeline, creating the numerical pipeline, create a new cell. Not there. I wanted it to be still under building numerical pipeline, but now before. Yeah, there. So let's create numerical columns. numerical columns is equals to now x train dot select d types brackets include is equals to now square brackets. We want everything that is an integer and everything that is a float. So quotes int, quotes float. Float. We want the column name, so you'll say dot columns dot to list. Dot columns dot to list, dot to underscore list, or here that one will work. It's a method, so bracket run print them to know how they look like. So I think senior citizen is there, so you'll have to drop it. Drop it, use the list method remove. So between the print and create another line between where we have created the variable name numerical columns and print between there. So we want to remove senior citizen. So you'll say numerical columns dot remove. It's a list method dot remove in quotes senior citizen. Run. I think now it's okay now. We can proceed with our pipeline. So we have stated that these are the pre-processing steps. So NAM, I've said it tells scikit-learn that these are the numerical columns. Numerical pipelines, this is a pipeline that will be doing the transformation. Then after that, we need to state the columns, and the columns are, we've named them numerical columns. What's his name? Yeah, now numerical columns. Numerical columns. Now close the bracket. Remove that space and then comma, not there, outside that first bracket, that red bracket, or is it maroon? Now jump to a new line. For now we're doing for the categorical, so brackets, normal brackets. So in quotes, cut, right cut. Then comma, the pipeline is cut pipeline outside the quote, that is. And then the columns that are being processed, they are categorical columns. Categorical columns. Okay. So you can run that. So the next step is we are training now all possible models that are used, that we can think of, that are used in classification. So for us, I think I want us to use logistic regression, KNN, random forests. Yeah, maybe we'll go and research on the rest. So I want us to import a few models. So the first model will be from sklearn.linear_model. Import logistic regression. Logistic regression. The next model is KNN. So from sklearn dot neighbors and just and yeah, neighbors there. Import k neighbors classifier, capital K neighbors classifier. So KNN can be used for both regression and classification. But since our task is classification, we'll use k neighbors classifier. The next one is random forest. So from sklearn dot ensemble So we are using random forest classifier. There's a question in the chat. I don't know what you are asking about. My look, could just unmute and tell us. No, hiyo ni hizo picha naweza tuma kwa hiyo namba. All right, so after we've imported now, the next thing is we'll train all these models. The one that will perform best is what we'll be picking. So we create like a loop. I think we can create a dictionary of the models. We look through the models as we evaluate everything at a go. So create a variable name, pipelines, because now we'll use more than one pipeline. So pipelines is equals to create a dictionary, curly brackets. Now I want has to separate each model by its each model to have its own line. So we'll start with logistic regression as the key. Then colon, these are dictionary key value pairs. Not semicolon, colon. Colon, then just remove the quotes. So pipeline, capital P, pipeline, brackets, normal brackets. Still inside the brackets is a pipeline, the green brackets. Add square brackets. Now in another bracket, normal brackets. So in quotes, add preprocessor. So these to tell a scale, and this is what is preprocessing. Preprocessor, comma, outside now the quote, comma, preprocessor. We also named our preprocessor preprocessor. So preprocessor, no, still we do not need another quote because we have a variable named preprocessor, Apogee. Preprocessor. And then outside that bracket, that one bracket, comma, just go to the next line. Brackets, normal brackets, model, in quotes, model, comma, and logistic regression, like that. We are calling the model now. Then in brackets, normal brackets, set maximum iterations, max iter, max underscore iter, max underscore iter. Yeah, like that is equals to 1,000. Max iterations in logistic regression is where the model is trying to correct its mistake 1,000 times. So the model will iterate by itself 1,000 times, try and correct itself or the errors that it has made. So that's the first model that we have. The next one is KNN, right? So just outside that, not that bracket, again, the bracket that is after that now, between the curly bracket and the normal brackets, add a comma, then you can backspace, add Imali logistic regression equal, we add the next model. In quotes now, let's add KNN or K neighbors classifier. Separate now with the colon, it's a dictionary. Copy that pipeline to the replace to upload them where the model is instead of typing everything afresh. Yep, copy that. Paste. Now, where there is a logistic regression, we'll replace logistic regression with k-neighbors classifier. K-neighbors classifier. Remove the regression part, and then replace max iterations, max iter with n underscore neighbors. N underscore neighbors, we can set them to be 7. So this is how KNN works. KNN works by, makes the assumption that data points with similar characteristics tend to cluster themselves together. So for example, if we are classifying what? Let's say we are classifying, I don't know the example I can use. Anyway, so based off that assumption that similar data points with similar characteristics, they cluster themselves together. When you now have a new data point, how KNN works, it will look for the closest neighbors. So to look, let me just share my screen and show you how it works. Let me share my screen briefly. Yeah. Okay. So I was saying in KNN, it works by classifying data points that share similar characteristics. In our case, we are classifying, say, for example, fruits by their crunchiness and their sweetness. So apples tend to be more crunchier than oranges, right? And oranges are less crunchier, but for the case of like Pixies, they are slightly more sweet than apples. So they are more sweeter, so they'll be cluttered or clustered closer. Apples will be clustered to closer because they share that characteristic. Now, if you have a new fruit that you want to classify, this is how KNN works. KNN looks for the closest neighbors. That is, if you state, for example, then n neighbors as say, for example, 3, it will look for the 3 neighbors. So for this case, it's 3. So the closest neighbors, majority neighbors, are oranges. So the new fruit will be classified as an orange. If we make the closest number of neighbors to be checked as 6, KNN will check 6 closest neighbors. So when it comes to KNN, always avoid using an even number when it comes to number of neighbors to avoid ties. So you can see now, for example, in this case, there is a tie. Yeah, in the votes, apples are 3, oranges are 3. So what the model will give you will be purely out of guesswork because there is no majority vote apple. So always use an odd number when stating the K value or n neighbors. So that's basically how KNN works. Mary, I think, can share back your screen. So we state the number of neighbors as 3. Can add this metric is equal to comma metric is equals to, in quotes, still after n neighbors is equal to 7, comma metric is equals to, in quotes, write Euclidean, Euclidean, CLIDEAN, Euclidean. So Euclidean is the type of distance, the one that we've seen from that new query points to the closest neighbors. So Euclidean is a distance. So we can go to the next model, which is finally random forests. Add a comma first, yeah, and then the next model is a random forest classifier. In quotes, colon, then paste the pipeline. We'll just replace the model. So where there is, okay. So where there is that K-neighbors classifier, replace it with random forest classifier. Random forest classifier. The hyperparameters are n estimators, n underscore estimators. Can state them to be 1,000. And then the other parameter is what? Max depth. So replace metric with max depth. Yeah, max underscore depth. So random forest is a model that is made up of many other models called decision trees. So that's where the name forest comes from. So max depth, you can give it 10. So n estimators is the number of decision trees that random forest classifier has. Then max depth is how tall is that decision tree. So I want us to look now through that dictionary. We'll train and evaluate all of them at once. Pick the best one. There are other models that we can use in classification, but for today and for the purposes of time, we'll have to just use these three. So a new line. We are now creating a loop. Can just add another line to separate the two parts. Yeah. So you will say for model, comma pipeline. Pipeline. Poleni guys, we were less of internet. Safaricom also decided to do the thing. So can proceed now. We were creating a loop, right? Let's give the physical guys like 2 minutes to set up. Go and share screen. Yeah, tuko live. Okay, so after that, comma, so for model pipeline in space in pipelines dot items. So we are looking through that dictionary, pipelines dot items, bracket after items. Now indentation close using the colon. Then I want you to print just for us to be able to separate which model is which. Print the thing that we created there, hyphen times 40, comma. So you will in quotes hyphen times 40 times 40, comma, model, comma, then in quotes hyphen times 40. Times 40. Okay. Next, a new in a new line, pipeline dot fit. Pipeline dot fit. So dot fit, we are now training each model. So for each model, we are training it using now brackets x train x underscore train, comma, y underscore train encoded. X is capital letter. Y encoded. Y train encoded. After that, now we can do the evaluation by saying create a variable name ypred. No, still in the loop, not outside the loop, still in the loop. Create a new variable, just tab. It will follow the same indentation. Mary, just tab, press tab. Okay. Code again. Oh. Mary, we're supposed to do like on a new line. So that one is supposed to be closed equals hour. Yeah, new line, but still in the loop. Now we are creating predictions from what each model has trained. So ypred is equals to pipeline.predict. Pipeline.predict. And we are making predictions using the X test. So brackets X tests brackets, capital X, test, underscore test. So remove that X minus, yeah. After that, I want us to evaluate now. It's for each model that trains, we'll be evaluating it. So another line still in the loop. Print brackets, quotes classification report. We'll be using a classification report. Classification. I think we didn't import the classification report, but check to import to say. Scroll while to import where we're importing. So we import the classification report. So we'll write from sklearn.metrics. .metrics import classification reports. Lowercase, yeah, like that, run. Scroll. Just scroll where we were. Yeah, classification report. You can just break it using the first /n, still in the quotes. No, to break it, napanga space /n. That's / n. Then outside comma, outside the quote, comma. All right, classification report. Classification underscore report. Brackets. We are evaluating two things, the predictions and what was actually there. So YPRED. Huh? Is it YPRED first? No. Y test encoded, then YPRED. Y test encoded, which these now are the actual values, comma, YPRED. These are the predictions of your model. YPRED. Like that, comma. So because we encoded our columns, we need to decode them to do what our categories, that is target categories. So we'll write target names, target underscore names is equals to LE, the name we gave the label encoder, LE dot classes dot classes. Yeah, like that. The classes should have an underscore after. So we can run it. Run the cell. Control enter. We have an error. N neighbors. Scroll. There's no U. It's supposed to be N neighbors. Another one. Pipeline.fit. No, it's under predictions now. Pipeline, not pipelines, because it's a loop. Yeah. Just scroll back to the code. Kuna wenye hawaja maliza. Sile yenye kapo nje.
Tuandike kwenye the same paper na okay.
Kwani hii imeandika nini?
Nimeandika with friends kwenye
Hii kwa backslash kwanza. Hivyo? Hii change it to backslash na forward slash. Pipeline.fit. It's external to get that the variable.
Sorry?
I'm just linking out external code to external code. I could restart the whole thing. Probably it's like a shiny. Pipeline yenye tunatumia tumeweka hizo pipelines za model zote scroll kwa one dictionary. So hii ni pipeline ya KNN, hii ni ya Random Forest.
So do you need to define your pipeline model, pipeline?
So to look in a dictionary, nasemanga for key, comma, value. So for key, which is
Model,
value,
which is a pipeline.
in pipelines.items, strings,
The
and then key is gonna, because this is the same as this, that fits extreme, comma, white, and I don't know what it's using on either. I want indentation, but I don't think so.
So I pick up pipelines.
No, because we are looping now through each
Through
pipeline.
pipeline.
Yeah.
Then that means like
We pay AI one. My copy.
Sorry.
Just copy the whole letter. These are 3 dots up. Copy and copy output, cell output. Walai.
Surely.
Wongo. We'll go back to where you stated the Random Forest model.
I stated.
Yeah. But it's not like it's not supposed to be written. Everybody got the chat one what specifically.
Transformer.
No, I think in order. Because you've already done that. Yeah.
Yeah, in electric processor.
Yeah. And like for categorical, we run everything from the top.
From here.
Like run all codes. Run like a zero. Yeah. I think still the error is persistent.
Persistent.
Just copy from where you created the pipeline. I think it was
Yeah,
the pipe, specifically the categorical pipeline. How to create the only catch pipeline up.
Oh, here.
Yep.
Copy this.
Next, column transformer.
Column transformer. Yes. And then
yeah, copy the whole thing. Control A.
Problem is here.
Second transformer is incorrect. Yeah. And
This just was. Categorical column. Okay,
Mali create, just go where you created that categorical pipeline. Is it the same variable?
Here. Okay, this is create.
Oh, scroll to me. Yeah, but what cuts the pipeline.
Pipeline.
I don't know anything from the top. Yeah. I think it's okay now. So we have the results of all the models. We have the first model, which is logistic regression. So I have a question, probably to guys who are cohort 7. Which metric will we be looking at upper or any other cohort? Which is the metric that will be focusing on mostly? Anyone? We have a try by Joseph Ng'ang'a, F1 score. Nani mwingine anataka kujaribu atuambie? What will be the metric that we'll be looking at? So anyway, in this case, because the target classes are really imbalanced, you won't look at accuracy. Accuracy will be misleading in this case. So what we'll be looking at is the F1 score of each and every class. Also, we can look at metrics like the precision and the recall. mostly precision. Yeah. So model yenye it has higher F1 scores is what will be peaking. So if, for example, the F1 score for the majority class no is 0.87, that is for logistic regression, and yes is 0.61. And for the KNN model, it's 0.84 and 0.56. So KNN tumeitoa because the F1 scores are really lower than the logistic regressions one. Random forest, same case. We'll click the scrollable element hapo chini so that we can see everything. Scroll chini kiasi, Mary, and then click the scrollable element. And then we have actually the best performing model here is logistic regression. It has the highest F1 scores. So because we've selected F1 score, not F1 score, logistic regression. Now, logistic regression is the model that we'll be going with. We'll now go to the final step, not final, I think second final step, which is now we are creating the pipeline of the model that we work with now. So just copy the logistic regression pipeline instead of typing everything afresh. Logistic regression. Exclude the comma just up to where the bracket is ending. And then you'll give it a variable. Remove also the logistic regression key and the colon. Yeah, remove the two. Remove that logistic, the whole logistic regression word and also the colon after. Then we'll give it a variable name, full pipeline. Full underscore pipeline is equals to pipeline, then preprocessor run. Then you are training now the final model, train the model. So after this step, you are typically supposed to do some hyperparameter tuning to see if the model performance will improve, but we won't be able to do that today. So training the final model. And then before the full pipeline, you can just add a markdown overlay to select the best performing model. Run. And then now we will train that model by using full pipeline.fit. .fit. So just fit again using xtrain and yeah, Y-train encoded. White train encoded. Can train the model, just run it. On input, I will scroll through. I think I know where the issue is. It's white train encoded, not white test. White train encoded. Run. Yeah, it has trained. Cameraman, piga picha. Piga TV picha. Yeah, so since the performance is the same, I think there's no need to evaluate it again. So the final step is we save the model. We save that model. Yeah. Yeah. Standard scaler is what maybe you can scroll up Malicodico. There's some who haven't finished. There's a question by Amai Luke.
My question is how have you figured out that it's returning the same result? Because I haven't seen anything that shows.
The results.
Yeah.
Since we are using like the same pipeline, the results that we've gotten when we were looping through all the models will be the same.
Oh, okay. I get that. I thought there was an evaluation of sorts that you had noticed or seen that probably you want to observe and all.
No, but still we can also add the evaluation bit.
Yeah, I see the point, because it's still going to give the same result. We're using the same information. Yeah.
So typically you are supposed to do hyperparameter tuning. That is, try and tune the hyperparameters, which is, for example, the max iteration, the log loss. Try and see if they can improve that model.
Okay.
Yeah, but because of for the purposes of time, we won't be doing that today. But that's a typical next step, and then finally you save the model.
Okay. Thanks, sir.
You're welcome. Sorry? Oh. So I think we can proceed. The next step is just a sec. So the next step is saving the model. So I want you to import joblib. So joblib, you can save the model into either joblib or a pickle file. So the difference is that joblib is more optimized. So I'd recommend you to use joblib regularly more than pickle. But joblib ni pickle imeomoka. All right, so after I import joblib, we'll be saving. So final step, in Markdown, just write final step, import joblib. So that's the final step. We are saving the model.
Could you repeat?
Okay, so saving the final model or pipeline, saving the final pipeline. And then encoders for the targets. Yeah, so we'll start with the target, which is the encoder. So just create a comment there, save the targets and encoders.
Ni kama I'm lost.
Targets, like remember we label encoded the target column Y. So to save hizo encodings, the Y. So first, nani hajamute, kindly mute. So just create another folder where we will be saving this. Call it models. click anywhere huku chini mahali kuna white space so that because yeah, now you can create a new folder, call it models here. I think you may create like a file. It's supposed to create a folder. So what we are doing when we are saving a model, we are essentially, that's whole process, that whole pipeline. What we are doing, we are suppressing it into a single file. That pipeline that we created from transforming columns to numericals, we are just suppressing it to a single file. So now we can save. To save, we just say joblib.dump. Joblib.dump. Dump brackets LE, comma, that's the name we gave the label encoder. LE, comma. Now, in quotes, you add the directory where you want it to be saved plus the name. So I want you to put it this way: two dots, / models, the way you've written, we name the folder models, / now we are saving it as labels, target labels, target underscore labels. .joblib. You need to add that file extension, that .joblib. That's for the targets encoder. Now next is the ML pipeline, machine learning pipeline. So we save the ML pipeline. We're using joblib.dump. We are dumping the full pipeline. So brackets, full underscore pipeline, comma, Oh, sorry guys, internet is acting up. Kindly bear with us. Actually, that's how it's supposed to be. When you want to save the model, you can now run that cell. So if you check under the models folder, you'll see those two files, the target labels.joblib and mlpipeline.joblib. I hope everyone is there. Anyone who is stuck? Erickson Mugendi, can you raise your hand?
Yes.
Sorry?
I'm experiencing an error from
Okay.
like two steps ago.
You can share your screen. We debug together.
Yes.
Okay.
You can see my screen.
Yeah, I can see your screen now.
So here is where the error started, where you are creating the pipelines.
Just scroll to the error. What does the error say? All estimators should implement fit and transform or can drop. Okay. To scroll to where you created the pipelines. Preprocessor. So what we were printing where Apple Jew, where you are saying times 40, you're supposed to, we are looping through each model. So times 40, then comma, model, comma, times 40, so that it will be able to read through the performance of each model. So model, stretch model.
Model. There.
Comma. Like that. And the pipeline.fit extreme. So possibly your error is not coming from there. It's coming from where you are creating the pipelines. So scroll up.
Here.
Yeah, so this is the first error. Did you call you haven't imported standard scaler? So Mali, uko juu, where you imported one hot encoder, just add comma standard scaler. It's there. Yeah, run that cell. Now scroll back to the first error that you have.
Hiyo ni ile ya kuunda ile nini ilikataa pia. The table.
No, that one. I run, try to run it again.
Still an error.
Oh, so the way you imported it's supposed to be camel case. I'm sure the second S you wrote in small letter. It's supposed to be all capital. So I think it's okay actually. Okay, restart kernel. Is it working?
May restart what?
There's a restart button hapo juu. Not there. Chini kidogo. Uyoni bado? Umetoa mali. You see where there's run all.
Or run all.
Not there. So there's that ribbon, mali kuna your chan. Yeah, so go to the left, towards the left straight. Still go to nitakwambia tu. You'll see restart.
Oh, yeah. So I run again.
Yeah, try to run everything from the top.
I run one by one.
No, there's a run all option hapo juu. Where there was restart. Where there was restart.
Oh.
Go to click your go to the first error that you have. Let's just start with that. So you can see you've written Chan as San. No. Hey, you're from South Africa.
Capital C, right?
No, small c, lowercase.
Okay.
You have an error. I don't know where it's coming from. No rendered for image. So there's an issue with the file extensions, but we'll deal with that later.
Yeah.
So which is the next error? Scalar. Numerical pipeline. Let's see. So you filtered out. I hope you first filtered out your numerical columns, right?
Yes.
So why is that error? Where is that error coming from? Standard scale is not defined. How? And I can yeah. Spelling a standard. Thank you, Grace, for that. You've written standard instead of standard. Yep, that's John.
This way. That's,
yeah.
This okay.
It's supposed to work.
Yes, it works.
Noel is requesting someone to share with them the code for step 6. Someone to share step 6 code with Noel Mwami on the chat. Preprocessor
not defined.
So
process.
Yeah, run that cell. Even though it's not is okay. Run everything. Run all 10. Run all 10. Hopefully it works.
Akata.
Numerical columns. Ulizitaje kwanza? Numerical columns. Yep. Numerical pipelines. I don't know why. Probably it's naming. Ebu scroll to juu kidogo.
Pipeline, sema pipeline.
Numerical columns. Numerical columns. Erica, yeah, I'll share the resources. Okay, for me, I don't have the code. We are writing everything from scratch. So, numerical columns. Numerical columns. Run tena. See, that's the way you run that cell. Yeah, that one. Extern is not defined. Yeah, atari. Abu scroll to where we are creating extern. So you can see your extern that you called up chini is lowercase.
Small. Yeah.
Run. What is the new error?
Extrain is not defined.
Hey. Scroll to where you are splitting the data. Run. So you inconsistently named extern. I'm the same. I mean, it's supposed to be capital X, capital X when naming extern text. Yeah. Run. Cat pipeline is not defined. Go back to where you are creating the categorical pipelines. Probably you didn't name it here.
It has worked. Eh?
Oh, okay.
Yes, I think it was the naming on the columns. See this one.
So we've saved the final models. So the last bit is deployment. We won't take long there because we are just creating the class. The first we are creating just a Python file to set import the class or the model, import the fast API class, state the schema. Full pipeline dot fit extra tuple object has no attribute fit. I will go to where you are testing the model. Ulipass nini? Xtrain, now I train encoded. I will copy your pipeline dot fit vileiko because that has worked. I don't know why it's not working. Coaching.
You test up, huh?
Yep. and then we'll add just a full pipeline before. Paste.
Nimepaste, mbona ina load kama ni
Yeah, I think that sometimes Jupyter notebooks zio active. But it's supposed to work.
okay.
See, copy issue ni probably it's taking for Jupyter Notebook to render that text and paste it.
Okay.
So you'll try to nini it by yourself.
Okay. No worries.
But,
Thank you.
you're welcome. Okay. So maybe you can share back your screen to malizia this thing.
Yeah.
So we are now deploying. So we will there's that folder we created called API. So in that folder, we'll create a Python file now. We call it main.py. Yeah. Can call it main.py. PY. Yeah, you're now creating the APIs. So you will import joblib. Next is from Fast API, import Fast API. From Fast API, import space, import Fast capital F, Fast, then API in caps. It's a class or camel case. And then we have from Pydantic, import base model, capital B, base, and then also M is capital camel case. AP and I also are supposed to be capped. So the way Shaq umeandika kwa capital A, capital P, capital I. Yeah. Hizo zote kutoka API zinafaa kwa caps. First API. Then import pandas as PD. As PD. So the next step is we'll be loading the models that we had saved. Yeah? I think to install Ama. It was part of them, but if you haven't installed them, can just pip install in your virtual environment. Pip install Fast API, Pydantic. That you'll use now the terminal for this. We'll install Fast API, Pydantic. I think Uvicon. Yep. Install Fast API, Uvicon, Pydantic. Fast API lowercase, Mary. So Pydantic, what it will be doing is it will be stating the schema of how the data set will be loaded to the model. So it helps in error handling. That is when for example, you enter data type that the model wasn't trained using, it will raise an error that you can easily debug. Yeah. So basically, Pydantic helps in setting the schema and error catching when it comes to the data types they're using to predict on your model. So Pydantic, Fast API, and Uvicon hazikuangi kubwa, so it's supposed to be done. So first we are loading the model and the labels. So you can add a comment, load the labels, put the labels. So for the labels, create a variable name, say labels is equals to joblib.load brackets. Now you add the directory where your model is in quotes, and our model was in the model /models/. You need to add, Mary, you need to add 2 dots before, then /. This only works if you are in that working folder. So then / the name of the model, of the labels, you name them target labels, target_labels.joblib. Labels.joblib. And then we also load the model. To load the models, just add a comment, say model, load the model. You'll do the same. The name of the model, HTML pipeline. Twitter ML underscore pipeline dot job lead.
Hello. I want to go. Can someone else share the screen?
Anyone else who would like to share the screen? But Jabakisha part kubwa. Just finalizing. We'll create the APIs and then tutafungia hapo. Jabakisha like a really huge part. Ama you really have to go now.
How long will it take?
In the next like 30 minutes will be done.
I have to go. Maybe I'll be back before the 30 minutes. The session is being recorded.
Yep.
All right. But I'll kindly request maybe you can share the file after you guys are done deploying.
Personally, I'm not doing the coding. I haven't done it. So maybe someone else will share. Which group are you in? WhatsApp group so that they'll share with you.
Cohort 6.
Oh, okay, so.
Okay, thank you.
You're welcome. Chuck, unaweza share screen yako? So the first die monitor. Yeah, showing. Unaweza close the terminal now. Yeah. Maybe you can zoom in. Kiasi tu. Yep. So next step is we instantiate the first API app. So we'll say app is equals to app is equals to first API then brackets you can add some information like title. Yeah, title is equals to, in quotes, customer churn API. Add also like the version, comma, version you can say 1.0.0. Yeah, iko sawa. So the next step is we will now create a schema of the features that we have. So from that base model will inherit from that base model class. So we are creating another class now, a child class from the base model class. So in a new line, class separate it, yeah, you go class and then name it input. No, like name it. Name the class input.
So the class like this, and
Space.
Yeah.
Input camel case. Camel case. That is supposed to be capital input. Then brackets, we are inheriting, there's no space. We are inheriting from the base model. Yeah, like that. So you add methods like that, column. So go back to the Jupyter Notebook. We list all the predictor variables, how they were named, the columns. So just say xtrain dot columns. Yeah, creates a new cell. We want to reference the names of the tests. So xtrain dot columns run. Actually, the best one that we're supposed to use, instead of columns, use .d type so that we can know the specific data type of each column. No, just remove the columns. Go to .d types. D types, like that. It's an attribute equal to because so the way imeandikwa hapo, you can see gender is a string, senior citizen is an integer. So I don't know how we'll do it because we need to state the data type and then the column, yeah. Exactly how it's written here. So ama unaweza copy uweke hapo chini, tukimaliza tutai delete this output, yeah. I go back to the Python file. Yeah, paste there. So I want you to under an indentation for your class tab, then you can start with gender, right? The way it's written there, gender. Colon, we state this is an integer, space, colon, space. String. No, string to str. Str, yeah. Then next column, senior citizen. Yeah, come on as a edit. So senior citizen, and then you'll ignore that 64. You andika to int. Yeah, then remove the 64. Do the same for all the columns. Right. Yeah, it's okay now. So I think the next bit is we'll create a get endpoint. To create a get endpoint. So you will use a decorator where you say at app dot get. It's a get is the endpoint. So we have zinaitangwa the CRUD operations in APIs, REST APIs. So what get does is supposed to fetch something from the server. And we will have another one called post. Post is where you upload something to the server. For example, when you post and you upload an image, what you do is a post. This is a post CRUD operation, or get you only reference from what is already in the server. Post, you are adding something to the server. You have another one called put or update. Just as the word says, you are updating the server. For example, if you had registered, assume you have an account somewhere, an online account somewhere. Maybe you entered your date of birth the wrong way. Now that process of appending your dates is the behind the scene. The operation that is being done is a put operation. Then finally we have, I think, delete. So it's delete from the server. So get, and then this is decorator. What a decorator does, in a supplement what is existing, you are modifying. No, like you are supplementing a functionality of a Python function, of an existing Python function, by adding that another extra functionality over it bila modify. I don't know if that makes sense. Go search Python decorators. Ulisha is just a single window. Decorators. Yeah. So just add Python decorator. They were more specific. Actually, it's the same. So decorators, you could have used the same W3 schools. So decorators let you add extra behavior to a function without changing the function's code. So the function yenye tuna refer inside Fast API, there's a function yenye imecreatwa named get. So what we'll do, we are just adding another function on top of get function to do what as we want, what we desire now the function to output, without specifically modifying that function yenye co-created inside Fast API. So what we are calling using a decorator is that function, the get function. Yeah. So get, then brackets in quotes tutaandika health /health. That's the endpoint. Health. So health will be like the endpoint. This is what we'll see to run kwa browser using UVCon. then now we can now define our own function in a new line. Just enter. Yeah. So the new function that we'll be writing ndio ina ongeza functionality a get without actually modifying. So define, no, there's no indentation, just write it from the start. Yeah. Define, call it health check. Not def.
Oh, it's a function.
It's a function.
Ah,
We are creating another function that,
got it, okay.
yeah, define another function that alters now the behavior of the get. Then just empty brackets because it's a tunataka tu tuambie if the API is running. So close with using a colon. Then in a new line return, you want that endpoint to return in a dictionary space, in a dictionary space. In quotes, we want it to return the status. Status, then colon. Then in quotes, we want the API to run successfully. So it will supposed to any just any API is running or something.
Oh, sorry, API ran successfully.
Yeah.
Oh, runs.
Actually, it's supposed to be is running because we'll see it in action. Yeah, then now the final API that will be predicting using the model is our post. Yeah, so you'll write at app.post. At app.post in quotes / predict. The endpoint will be named predict. Now define that function, define predict. Yeah, just name it predicts also. Also, we wanted it because this is the API that will be doing the actual predictions. Now you'll define predicts inside the brackets. You'll add payload, comma, separate with payload separated with a comma, and then in a load on your end, on our end. And then you see that schema we defined hapo juu. Yeke hapo sasa. Yeah, the input class sasa. Yeah. Now after that we just in a new column, in a new line. Remove the return. So input df, create a new variable name, say input underscore df, still under the indentation of the, yeah, input underscore df is equals to. Now we are creating a data frame. So for every input that we'll be adding to make a prediction using the model, we'll be converting it into a data frame. So we'll say model underscore pd.data frame, sorry. pd.data frame. It's a class. Then brackets, square brackets, payload.dict. We are picking a dictionary from the class. Chuck, uko sure hii kitu iliweka colon? No, not after. You are supposed to separate payload and input with a colon. Pia, that one is supposed to be a colon. Yeah. So payload.dict. Add another bracket, normal bracket after. Yeah, it's like a method. I don't know why it's raising that thingy, but tuendelee tu. Then now we want to have a predictions, the row prediction. So give it a variable name, row prediction, or prediction, just give it prediction, a new variable name, chini. Prediction is equals to which variable did we give our model that we said hapo juu when we were loading? We give it model, so it will be model.predict, and then in brackets input the underscore df, then outside square brackets 0. So we want the fat 0. Yeah. So after that, we want to decode the predictions. To decode to me inverse transform. I will just say this. Return, add a return. Opportunity, this will work. Return, then in a dictionary. Yeah, space dictionary. Create a dictionary. Yeah, like that. Then in quotes, prediction. Separate it with a colon. So we'll say prediction dot, it will still work, but prediction dot inverse transform. Is this work well? Underscore transform. No, nimekumbuka, it's LE. Wait. Label encoder dot inverse transform. We'll try remove the prediction. LE dot inverse transform dot inverse underscore transform. Transform brackets. Now you'll pass in the variable name prediction. So tuende kwa terminal, activate your virtual environment. I hope I raise any errors.
It's on.
Yeah, actually it's activated. So tunatumianga hivi con is hapo sielewi. Ah, yeah. So I think it's supposed to be the labels dot inverse transform. The way we loaded the label. Yeah. Labels dot inverse transform. I hope that will work. So hakuna mali we've used a scalar here, but it should be running behind the scenes because it's the one that is supporting the model. The most operations are in a scalar. So when we run, if you run this code without the environment where that model was trained, it arrays very many errors. So scikit-learn will be running behind the scene under the hood, as much as we haven't imported anything related to it over here. So unaweza fungua the terminal. Huh? Hebu we try. Ikikataa. So sijui kama tunafaa kuingia cd to that folder API, I think ndio Iran. Then nakwanga UVCon. Yeah, it's UVCon. Jaribu UVCon space main colon. Main, I think, is the file name. Colon app. And then space hyphen add 2 hyphens. Space 2 hyphens reload. Enter. Please. Perhaps you forgot a comma. That version being up. Yeah, I think that's what's causing the error. Maybe they changed how you're supposed to write it. So it is reloading by itself. Yeah, Bent, I'll share the recording. Is that up completely? Yes. There's supposed to be a link utapewa hapo to the local host. Just give it some more seconds. No, you're supposed to state the IP. I don't know. Gani? It's not found. Will you quickly install UVCon? I don't know. It's supposed to give us a link. Hebu enda on your browser tuone if it will work. So kwa link eka 127.0.0.1. Yeah, enter. It's not working. First pay works port 8,000 ndio. Hebu add port 8,000 back to kwa browser. One two seven zero dot one. Yeah. Enter. Not found. Weka /health. Docs. Eka /docs. Docs too. CS. Mm. No, it's internet again. We'll try it out. Try it out. Then you may drop down hapo. After parameters, try it out. Execute. Click that execute button. Click. So the output body. Yeah, response body is what now is telling us the status of the API. So you can see it's saying API is running successfully. If there was an error, it would have pressed something different. So, and you can see status is 200, which is okay. Now, let's try and do a prediction using the model. So go to the predict endpoint. Unmute. Okay, so predict. So able to understand how the entries were written, and then we'll add random guesses and see what the model will predict. Go back to the data. ML that means that model is not a scikit-learn paper, but a Python dictionary. About try kuprint weke kwa yeah, just copy it. Copy that code. About comment out hiyo nini yote. Hiyo code yote niko hapo. Then uta comment to your model yenye tuliload na model so that tumjue what model is. Yeah, the ML model. So paste your code uko chini. Yeah, nini, and then uta run using Python. Yeah. Hapo juu. Tumia kale ka play button kapo juu kwa kona.
Oh, hii play button.
Ituambie oh, and comment job lib.
Oh, see the models.
When the model is not being read, file not found, a search file or directory. Book copy, the way the whole thing is written up. This path, yeah.
Like
Right click. Right click. And then,
oh,
yeah. Just copy path. Paste it happen. Paste. Ongeza R because these are backslashes. Learn.
Good.
Sasa and comment out hizo zingine kama where the issue was actually. Who was the problem? Tutazi and comment nusu. Iko sawa? Ni control /. Yeah, iko sawa. Eti kuna actual comment.
Actual comment. So there is a model with a link.
Yeah, uta comment hizo za huko chini. But before the output here, this output so it will give ChatGPT to ambie where the issue was. Class leaked, and then yeah. So none of the model, the job lib file needed to that process has been saved into a single file.
Oh yeah, the process. Yeah.
You can see isn't of logistic regression pipelines.
Because model is a dictionary. So I can talk about dictionary.
Oh, okay. Quick fix.
Hello, excuse me.
Yeah.
Could the one who's sharing share like all the codes you've run in the main PY in the chat, and also maybe the codes that you've run also in the terminal up to where we are.
We try to debug what we'll be sharing in short. Just a sec. We're trying to debug something here.
We only use the best performance.
Yeah, so it's, instead of saving monthly pipelines, it was not supposed to save 3 pipelines. That should be saved where Burudi kwa notebook. When you are saving a model. Scroll. Yeah. Oh, you're supposed to save the full pipeline.
Oh, okay.
That's where the error is coming from.
So, it overwrite, huh?
Scroll juu kidogo or to confirm if we really changed it. Yeah. Run.
We run what?
Full pipeline.
Yeah.
The saving part.
Saving part. So it overwrites the
Yeah, it will override that one to have like a new version of it.
Okay.
So read it to the code, try and use recon again.
We recon too?
Yeah.
Yeah.
Loading could not import module main. Oh, you're supposed to first go to API, the API folder. So terminal control C.
Okay.
CD. So we are maneuvering to the folder API. That's good time. That's the menu we'll be using. Your 1 to 7, copy that. Control and the. Can click it actually. Alafu add because I was instead of using Chrome, actually it's even better. Add docs hapo mwisho. Docs like that. So you can try and minimize this. Don't close it. Yeah. Yes, you'll have to delete those linear again.
Oh, CD is a copy. Yeah, where is it?
Yeah, just copy the predictions.
So try to.
Yeah. Override. Executes. Hey, attached.
So,
oh, did we? Okay, I think it was our still. This issue, the issue be from. Now, if you able to try checking the logs Apache. What's not quite on? Able to check the path. It's the same path. I think And then the issue is hata ituonyeshi on the logs. Hebu kuja hapo kwa hiyo record ya juu hapa. Click there. But still hata hii set iko na shida. I don't know why it's not giving us a prediction. It's supposed to.
How do I unsplit this?
Just delete that using the delete icon. Why? Why? Oh, value error. Why should it be? Hello? Okay, guys, the online guys, I think we are facing an error that is can't solve now. But for the purposes of time, I think you can go and try and research, see where the error will be from. I'll share the link to the GitHub code. Shaq will push, and then I'll share with you the link in your respective groups. That is, I'm sure these cohorts 6, 7, 8. Yes, so I'll share the link with you guys. Yeah. Recording will be ready after almost 12 hours. So it will be ready after a few hours. Yeah, it's really long. So I'll share once Google shares the link to the recording. So I think that's it from me. Asante sana for making time for today's session. I hope you learned something. Yeah. Very. So let me stop the recording.